Tell me if we're back. I'll wait until I see people saying that I'm back. Am I back? Are we good? Awesome. We're back. Okay, so when I think about it, to make the equivalent classes, what I'm going to have to do, even if I do these edges, this whole thing with the graph, is I'm still going to have to mark which vertices I've already visited and skip them, which is what I could have done if I was just doing it directly without the graph. So we're going to roll this back a little bit and change tactics. Instead, we're going to do unsigned char dot marked columns equals unsigned char star malloc ls count 256. And what we'll do is we'll just say mem set that to, or marks is what we'll call it. Mem set that to 0. Right, so then once I have visited somebody, I'll set theirs to 1, and that means I will skip them in this loop here. So if I'm going along and I, getting ready to look at somebody, what I'll do is I'll say, hey, marks C equals 0, then I'll do this work. And in here, instead of all this nonsense, we'll just say, hey, marks C2 equals 1 now. Right, so don't visit this one in the future. So now we can just mark these things as don't compare them. And then the only other thing we need to do is to build up the equivalence classes. We just need to make little lists of what are all the things in this class that's equivalent. Like, hold on. Yeah, okay, so easiest way to do this is to say EQ class, and then what we'll do is we'll clear all EQ classes, or we won't actually, because we should end up setting all of them anyway. So let's just try to do that, and then what'll happen is while we're going through, unsigned char EQ class counter will start at 0, and for each equivalence class, what'll basically happen is I'm looking at my current column. Then I say look at all of the future columns, and well, first of all, set this guy's EQ class to the EQ class counter, right? Or wait, no. Set this guy's EQ class to the EQ class counter, and at the very end, we're going to take the whole thing and increment it. And then in the middle here, whenever we find somebody else who agrees with us in column exactly, who has, or like someone who's, in a particular input that behaves exactly the same as us, then what we'll do is we'll say, all right, then that class will also get this EQ class counter as its class. So when we come out the other end, we'll know how many classes we've found, and each column has been marked with which, or that should be C2, and each column has been marked with which class it's a part of. And this is the way we want to set it up, I think, because what we're going to need is a table that translates from inputs to equivalence classes, and then we can use that to make a table that translates from equivalence classes to the, to generate the table using equivalence classes, basically, right? So the goal will be that this table down here at the end will be generated using equivalence classes as inputs instead of inputs as inputs. But, okay, so let's see if we're at least building right now. We are. Now the table shouldn't be affected at all. If I reload it. Oh, it's funny how the proportional fonts make it look different with... anyway, it's not the proportional fonts, that's just because I'm not like padding out the numbers actually. If I padded out the numbers, they would all be the same. Anyway, because the numbers in this font are all the same width, which is nice. So anyway, we need to put a table before this table, basically. So here we've finished building up these EQ class things. Now what we want to do is just do a quick loop over that, and so we can make the EQ class table, which is all not too complicated. So here's the main FSM EQ classes, right? End table, and then I'll do a loop over that, and for each one of them I'll just do a table item into the file, which just takes the EQ class for that particular input and puts it in. So now I have a thing that's got a width of 256, and it turns each input into its equivalence class. That should be cool. No, it's not cool. You still need to know what file to end the table in. Gotcha. Fair enough. Alright, now we should have a cool looking new table. There we go. Where's the close bracket? Oh, it's just thrown way out there because I don't have like okay, so what you were saying I should do is end the row first to make it pretty. But there we go. Now we have equivalence classes. And what I'd be curious to know is a number of things. First of all, do any of them actually work? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It doesn't look like any of them worked. Every single one of them ended up being a difference equivalent class, which shouldn't be true because I know that some of these are equal. I know, for instance, that 1 should be the number given on the first two columns, but it's not, which means there's a bug. So, track down a bug now. Let's see. So we're doing a mem compare between C line and C2 line. And let's see, the assumption is C2 line started at it should really just start at C line plus another line, and then C2 now basically what we're getting down to is these two guys never come back as equal, which is, oh well, that's gonna happen because I did something wrong somewhere, I think. No, because we're plussing by ls count. That makes sense because that's how long each row is. Each line in the table is one ls count of length, and there should be some that come back as equal. All right, debug time. We can close. Whoops, we can close you. No. And we can open you. Oh, this is going to open a debugger for, this is not for the generator, so that's not helpful. So I gotta do this manually because I don't have a script set up for it yet. Dev env FSM gen, I believe is the name. Hopefully I got that right. Okay, wasn't loaded. Let me just do a quick dir to make sure I get the right name. Oh wait, gotta do exe on it, right. And I understand the suggestion you're making to mark them based on the columns they're equivalent to, but I want the equivalence classes to range from 0 to the number of equivalence classes. I want that to be how they're marked. So I don't want to have like 255 be an EQ class because I want them to go from 0 to some minimal number, right? And I think we're basically minimizing extra testing by doing the marks. We could obviously try to condense it so we don't have a marks array and a EQ class, but there's no point in that. That would be overkill. Dad, get out. Get out. Stop. Stop. Whatever you're doing, stop. No! Didn't mean to do that. That's kind of weird. Why did that happen just now? Oh, I'm not in the right directory? What does that have to... Oh, it's loading for... Okay. I see. Back to code. There we go. Alright, so I want to go to test. We need to look at some things. Tables.c. We need to look at FSM. Well, I want this over here. FSM table generator.c. And I want to see if I can build this again. Okay. Tables.c. Boop. Uh-oh. Uh-oh, what was that? What was all that about? That's crazy town. Tables.c. Yeah, it's still not working. Those should totally be equivalent. Alright, close you, because apparently you're causing bugs right now. Table generator.cpp. Because I can't release it yet, because now there's two of them. Now there's two things that aren't working right. I wonder what that was. Yeah. Okay, so what's going on here? It's not doing anything that it's supposed to do about this mem compare. It's not necessarily doing what I expect, maybe? I don't know. Okay, we'll take a look. We will take a look. Yeah, every single one gets an EQ class. If C is already marked, we skip it. Otherwise, it will get an EQ class. Oh, it's getting a new EQ class there. There's your problem right there. Got it. Tables.c. There we go. Now we're getting equivalence classes. So those three are all the same. Then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I wonder why these are all different. 23, 24, 25, 26, 27, 28, 29, 30. Because they're not even like in the range of useful ASCII information yet. So that's still giving me 253 equivalence classes, which is much more than I would expect. Like 111. You're telling me this column here didn't become a 1. 10, 11, 12, 30, 31, 32. Yeah, that should have become a 1 too. So there's still a bug. Okay, so we started off at 0, and we said, look, if your mark is 0, which it is, you get a new number, and we check everyone else for equivalence. We don't find anyone who matches him, so nobody else becomes a 0. We increment the counter afterwards, and we go to the next line. Then, if that particular line is equivalent, or no, if that particular line is unmarked, which that time it is, we then set the EQ class again at position 1 to a 1. And then we grab the next line over. And when we're looking at the next line over, we do a mem compare. And if they're equal, we set him to have the same EQ class. And then we increment C2 line. Now we do that a couple times, and then suddenly it stops thinking of them as equal, even though it's clear that a ton of these are exactly the same. Right, so why does it find them not to be equal? Okay, so let's step into it. Oh, the code. Okay, it better not give me like. I was worried it's gonna be like, oh, the code doesn't match. It's mismatched. Blah 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 blah. All right, here we go. Equivalence class stuff. So we get through to here, hopefully having filled the full transition table up correctly. We haven't actually tested that anything is correct yet. It'll be interesting to debug. Maybe I should have done this a different way, but oh well. Hopefully it works out. And then we see what's going on. So I want to have all of the marks right here, and I want to have all of the EQ classes right here. And those are just garbage to begin with because we aren't initializing them, and we're assuming they all get initialized. Alright, so let's see. If that equals 0, C2 line 2. So we're looking at line 2. And then are they equal? And the answer is no, and we keep going until we either increment this or find somebody who's equal, and we never find anyone who's equal, which is correct, I think. I don't think anyone does the same thing 0 does. So then we go to the next C line, and now he's got a 0. Right, now here we are, this guy gets a 1 for his EQ class. We take the next line over, and we compare them. And, okay, so he gets marked. He gets an EQ class of 1. We go to the next line over. He gets marked. He gets an EQ class of 1. We go to the next line over. Alright, so we're on line LS. Oh, what is this? Okay, so that loop is just too short. So 531. And no, I don't, because I am only iterating forward. I don't need to mark things unless it's possible that I'll see them in the outer loop. I mean, I could, but I'm just, like, not overdoing it here. Alright, so there we go. Now a lot of things are equivalent to 1, which makes sense. Those are all, like, the ignorable characters, right? They don't do anything. And then, there's a lot of 22s. I wonder what the 22 class consists of. Maybe that's a lot of letters. Yeah, probably. And let's see, yep, then there's a bunch of 1s. 2, 5, 6, 7, 8, 7, 1, 8, 9, 10, 1, 1. So I'm wondering how many, like 17, 19, 22. Obviously there's an easy way to do this, which would be to say that after printing this first table, we'll do fprintf onto the file int num EQ classes equals, or we could just even do like we'll just do constant num EQ classes equals blah blah blah. Man, it's really weird running this with Visual or with OBS because it's like weirdly laggy. Let's see. Let's see, num EQ classes, blah blah blah, EQ class counter. Tables.c. I'll just kill it because last time I tried to reload it, it freaked out. Alright, so there's 28 EQ classes apparently. So that means there should be a 27 in there somewhere. Yeah. Cool. So 28 EQ classes is really, really good. I want to say, I'm not sure that this is true, but I want to see if I can find that. I'm just curious because I did that. I found those EQ classes by sort of number crunching them. against my finite state machine. I just want to see if I can find that old little write-up. I maybe favorited it. Did I favorite it? That would have been really smart if I did. Okay, cool. Equivalence classes. Curious to see how many equivalence classes were in the little version that Sean Barrett did. Two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 21, 22, 23, 24. Ah, 24. So mine has 28, whereas his had 24. So it seems like I've got a few more than him, but probably the reason is because I handle like errors and things, and I think it looks like, if I understand correctly, that he doesn't handle like these nonsense characters that don't really do much and stuff like that. So it's hard to say for sure, but I think 28 is a pretty good number to have gotten as a result. So it might be that I have like some spots in here that I could optimize. Like if I was making once I get the full finite state machine like equivalence class thing working, what I want to do is make like an optimizing finite state machine table generator that will find the optimal FSM for something, because right now we're just taking the existing FSM and like, you know, optimizing out equivalence class type things. But once I've done that, there's some like machine level optimizations you can do, like pre-multiply your indexes and stuff like this. That's kind of cool. But it could also be conceivably done that I then run a finite state machine optimizer that would see, are there any redundant states in here that we can eliminate, and then it might be able to pare down the number of states considerably, and that would be cool. Obviously, that would be really cool. Okay. Because if it gets down the number of states, it might be able to get down the number of EQ classes and make a very small table. And the smaller your table is, the better, because it just means that even if it's on even smaller caches, like even more of it fits on even smaller caches. But now, anyway, we now have this here, which translates an input character into an equivalence class. So now what I want to do is I want to reformulate this whole table so that I can look up an equivalence class in this table and then look up a state transition in this table without having to do this, have like these giant, because 256 wide, that's like at best like gonna take up 4 cache lines, maybe more. Like, you know, a 64 byte cache line is not uncommon at the L1 level, and I don't want it to be blowing out cache all the time at that level. I want it to fit in L1 cache for as long as possible. So having it down to a 28 versus 256 bytes is a big win per line, right? Because that means even more than a full line fits on one L1 cache line, which is really good. So especially considering that a lot of these states transition to themselves over and over again, like state 0, 1, 2, 3, 4, it just transitions to itself over and over again in this thing. So it'd be kind of lame to have to jump to a different cache line to just get more information that's going to be redundant. Okay, so we have these equivalence classes, 256 down to 28. So now this this table here is no longer the one we actually want to output. Now what we want to do is generate a new table that goes, let's see, so we've got that, and then let's do unsigned char. I just feel like I should do all of the code generation after all of the everything else. Okay, unsigned char reduced transition table equals unsigned char star malloc ls count times EQ class counter, right? Because that's how many EQ classes. Whoops, what am I doing? That's how many EQ classes we have now. And so that's how big this new table needs to be. And basically all I have to do for this, and it'd be nice if I had a reverse lookup thing where I could do, like, get an example of something from this EQ class. So it's like EQ class rep equals, and then I'll just grab another array of that size. And then every time I do this, I'll also add that to the EQ class rep array so that I have a reverse lookup back to a character that has a particular behavior, right? We're assuming everything in the EQ class has the same um, behavior, so I just need one representative from the whole EQ class to do the tests. Um, okay, so then we're going to regenerate this table, but what we can actually do now is we can stop doing the transposition that was weirding me out before. We can just say this goes up top again, which is cool. And now as we go, what we'll do is we'll say, all right, do we emit a token, set that to 0 to begin with, and then the character we pass, well, this here will just be EQ classes, not C, so instead of C, that's EQ class, no, I'll just call it EQ, right? And that should be less than the EQ class counter, right? And then, do we emit a token? We'll find out. To get this C, what we're going to do is we're going to look up in the EQ class rep from EQ, and that bug just bit me again. EQ. And then down here, I'm going to put in the reduced transition table, the new state after that transition, right? Then I'm going to run the finite state machine EQ. Yeah, so then I output that, I'm going to output that, and then I want to output the main FSM table. And when I'm outputting that, I was reading out of the full transition table. I want to now look at the reduced transition table. I no longer want to do Crazy Town right here, I just want to do I++ again. I still want to do it in that order because that matches the order up there. We don't need that, by the way. Yeah, so let's see if that works. 531, it does not work, as it turns out. EQ class rep. EQ class, you want me to cast that to an unsigned char star, or an unsigned char, I imagine. There we go. Tables. Tables.c. Uh-oh, that's not good. What's going on there? Oh, we're going on for too long, for one thing. Yeah, I think that's probably the #1 problem. EQ class counter. Okay, so now we're just getting a bunch of zeros. Why am I getting so many zeros for? EQ class counter equals unsigned char C. I input that there. I'm putting these things into the reduced transition table, and I'm pulling them out of the reduced transition table. You know, I don't even need to do this. I could like optimize this another full step, right? Because this right here is kind of silly. What I should do instead is just say that I'm going to memcopy into the reduced transition table. Actually, I can't do that because of the fact that, because of the fact the other one's not laid out the right order. Okay, so, I don't know, do I need to, like, reinitialize that to 0? Because the state is just being set each time. So the only problem is that's coming out as zeros. EQ, so I'm curious when I read out of EQ class rep if I'm getting what I want. There. Okay, so EQ class, we don't need to have 2 of these anymore. EQ class rep EQ. Let's just look at all 28 of these. Okay. Now, we come in here, and the character is a 0. Great. So, what happens on the next line? New state is still a 0, huh? What about in the full transition table? If I look at the first 256, or like, wait, no, how many states did I have? Like ls count. I don't know how big ls count actually is. Do I have a, can I get ls count in here? No, can't get ls count in here. That would be too convenient. So, we'll just, okay, we'll just look at the first 256. It doesn't matter. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, this is the full transition table. What does this mean? This means that 0, state 0, no, input, oh, which one is it? This is what each, I forget what, the full transition table is transposed from my expectation. So each column is a state. So that means I'm not looking across one state, I'm looking across the input 0. So this is for the input 0, and for the state 0, I would expect a 0. So that is okay. Now, what about in the next EQ class? The next EQ class is 1. We'll come in here, that comes out as a 1. So then, boop. And if I'm looking at, that's an input, this right here is also an input of 0. So I want to look for when we transition to, like, okay, boom, there's input of 1, so it's 36 was my answer. Okay, so it's like 256 times 36 is what I need. $92.16. Okay. Ba-da-da-doom, ba-da-ba-ba-ba-boom. Right, okay. So here I should also get a 0. Right? Yes, because we're talking about an input of 1 on state 0. I should get a 0 here. Okay. So let's say I went to the next state over. So I'm in state 1. Cool. Now, when I come in here, I'm going to get an EQ class of 0 again, and it should give me a 1. Okay, so I'm getting a 1 there. Reduce transition table. Oh, I know what happened. I didn't reset I equals 0, so it's just kind of bogus. Okay. Aha, there we go. Now our table is much smaller. We can see which state we transition to given whichever EQ class we're transitioning from. So like EQ class number 4 here, 0, 1, 2, 3, 4, you know, has this behavior. Now it should be true that none of these EQ classes are exactly equal all the way down. So just gonna double check that. Okay, so that's wrong because I can't actually tell given the fact that there's no padding there. Let me do something about that real quick. Oh, the spaces won't be enough because it's not. See, can't pad it out with spaces because then I would need to switch to mono font. Very well. And this is also why 4coder needs a table manipulation interface as one of its, you know, targeted features for not dealing with bullshit all the time. Alright, so there's a difference right there between this column and that column. What about here? Oh, there's a difference. There's obviously a difference between these two columns. Very cool. So now we have 20 equivalence classes and 36 states. And so our whole table is down to what? 28 by 36. Less than a quarter of a page, which is awesome. Alright. So, let me reload that. Okay, so what's the next thing? Oh, did I save those changes? Let's just build it again. Tables. Boop. Okay. So what's the next thing we need to do? Honestly, the next thing we need to do is to put this table to use in the actual Lexer. I can't think. Well, I can think of something else we need to do. We need to take care of the other smaller tables real quick and the emit token thing. So far, yeah, there's a few things we need to do. Okay, so basically, so far what we've done is assumed that that we're just totally okay with the idea of we need to see the there's two things we need to do. Okay. So one thing we need to do is we need to pre-multiply these. So what am I talking about when I say that? Basically, when you have an array that's more than one dimensional, you have a row here, and then you have a row here, and you have a row here, and so on, right? But in memory, this is conceptual, the fact that it's a grid, right? There's no actual grid. You don't have an item here and then an item below it. That's not true. In memory, all memory is one long line, right? So it's like, in reality, all you have is, let's see, how do you do this? Oh, there we go. In reality, all you have is that, right? Loop. And so if I jump from one row to the next, I go from that item there to this item here, right? And in order to do that, what you have to do is you have to multiply your index, right? So if I have this array that's two-dimensional, and I say I'm at state, 3, I can't just go, down 3. I have to do 3 times the length of the row. And so an idea you can do to optimize this, and there's not actually, I realize there's not actually a state 3 in this little thing, but like there's a state 2, right? So we'll say if I want to go to state 2 here, I have to do 2 times the length of the row. What I could do is pre-multiply the indexes that I store in my table so that they are already multiplied and I can skip all those multiplication ops. So that's the next thing we need to do. Okay. So the way that works out is that just means when we're printing out right here, this is pretty straightforward, we multiply by ls count, right? Because that would be, wait, no, that's not the width of our array. What's the width of this, right? EQ class counter, right? That's the width of each of these things. So if I wanted to go to state 1, I actually want to go to 1 times the number of equivalence classes there are, right? So this multiplies everything through by that. Now, one thing I need to do is, if I'm multiplying all of these out by EQ class counter, are they still unsigned chars? I don't think so, because this is 1008. So my main FSM table actually needs to contain unsigned shorts, as it turns out. So what I need to add is right here, char star type and now I can go to wherever I begin a table, and this right here can still be a char. Let's see, and where else are we? Wait, why can't this be... I just need to double check my logic. Why can't this be why can't it be It's because I'm saying that if I have a 36, I'm going to multiply that by a 28, right? That would be that big. I would have to divide it by, what, 4 to make it fit? That's crazy town. Because, like, even if I got it down to, like, 20 by 30, that would be too much. What am I thinking about incorrectly here? So, like, 20 times 30 is 600. So if you even got it down to 20 equivalence classes and 30 states, it would still be the case that pre-multiplied states would blow out the maximum value of like an unsigned char, which doesn't make sense. I mean, guess we can skip this optimization for now until I have a more concrete plan of how to avoid doubling the size of all of these state variables, because that would double the size of like cache misses, and it would still require a multiplication, so you'd just be losing all around because it would need a multiplication for the size of the type. So unless I come up with a reason for why this would work, I think I should back off. I mean, hold on. How many things are in this table? There's 0, and then 28, and then like 50. Yeah, it grows pretty fast if you think about it. How would you ever do pre-multiplied then? That's very interesting. Yeah, so the table's too big, and the thing I don't understand is you can't even get it small enough. Like, you can't get this small enough unless you get it down to 256, right? That would mean like 16 states and 16 equivalence classes, which is obviously not. You could pre-multiply the size of type, right? Because then you could put in the doubles and you'd get that back. But I think just to avoid avoiding a multiplication in exchange for missing the cache twice as often is not really a good call. Like, I would rather have half as many cache misses as, like, you know, as compared to one multiplication operation per every character of input. Um, yeah, I'll have to think about that. I didn't think that through enough to understand how that works. So we're going to say no pre-multiplication for now. We'll just deal with the multiplication in the code. And that only leaves the other problem, which is dealing with these emit tokens that we were ignoring initially. And this could actually mean that the number of equivalence classes goes up anyway, because what we're ignoring right now is the fact that we're ignoring the fact that right now sometimes we get a state back and it's not an emit, and sometimes we're going to get one back that is an emit. And the question I'm asking myself is whether I would rather keep the table small by not having just double the number of states, one for emits and one for not emits, or oh wait, no. No. I wouldn't double the size of the table. I just would need to know how many more equivalence classes we get, right? Because we're not going to actually have more states to put in the table because emit states don't have you don't transition from them. They're sort of your terminal states. So um, what I would need to do is just say when I'm setting up this original table here, not the only thing that changes is the new state becomes that plus ls count times new FSM dot emit token. All right. So given that change, do we compile? Not really. Okay. Oh, I need a type here. Okay. Well, I pulled this type idea out, and then I didn't actually end up needing it, but that's fine. Tables.c reload. So that puts us up to 30 equivalence classes. So that's 2 more. And that's a good idea too. He's suggesting that we can use just multiply add type instruction so that we can get that indexing done quickly. It's not the most pressing concern in the whole situation. Yes. I just keep asking myself if I've organized the data the wrong way, but it's obviously not true because you want to have the states be something you get to first, and then yeah, I just gotta go think about that again because I thought there was a way to make that work, and now that I'm looking at it, it doesn't seem like there is. Orlando Bloom, the Lexer is slow. It's slow, but not that slow. Like it's slower than it needs to be, but I don't really care. I mean, I understand the concept of that I should work on the things that need like new stuff sometimes, but like I also just don't always care. So I'm doing this because it's really fascinating to me. And if the flexor can be faster, I want it to be because that's what's fascinating to me about this little project. Is finding the idea that you can optimize things. Like on the one hand, optimizing something like math routines that are math heavy is one thing, but like finding ways to optimize this kind of thing is kind of really cool. Yeah, I've been thinking about that, and that like a lot of these are very not interesting states. Like this is the state 4 basically transitions to itself or to 5 in one case, which then usually transitions back to 4, although potentially to 6, which then they're all very not useful. But a part of this is thinking about low information densities. Like I mean, there's possibly a hint that maybe I don't know. It's unlikely that this can be reduced. That the finite state machine is can be optimized so that it has fewer states or anything. Um, but it's not. We're not really going for compression here, so that's not totally on my mind. Okay. So anyway, yes, we're almost to 7, but I'm really enjoying this. So I'm gonna keep going for a little bit. We'll just make sure we don't keep going through Handmade Hero. Okay. So we've got our main FSM table here, and in there we just get states, and then we are able to update to the next position and so on. And then oh, what about the equivalence classes? Hold on. What if you pre-multiplied the equivalence class? Is that what you do? The equivalence class right now it's set up so that whatever state you're in, you could pre-multiply the equivalence class, and then okay, this is really cool. Okay, so this is interesting. Um, we'll transpose this, so we'll do it the other way around. We'll do states going, as actual columns the way that I wasn't doing that originally. But we'll say states are columns and that inputs are the rows, right? And then every EQ, because the inputs are the EQ classes, and we can pre-multiply the EQ classes because that would just mean that when we pre-multiply the EQ classes, what we're just doing is saying that the EQ classes need to be shorts, right? And that's not as big of a problem because that's a smaller table to begin with. And then well, do they even? I would have to double see, but I want to just okay. I want to chase that down for a moment because that's interesting. But let's say okay. First of all, I got this emit token thing going on. So now we have a few states that are like they exist after a multiplication. So I want to scan through here and see if there's anything that's like a state that is larger than 36. I don't see them. Oh, because I haven't done them in the emit rules down here. So down here, when you were doing that, that should also be this, right? All right, let's try that again. Tables.c, tables.c. All right, now I should see things that were above before. Yeah, so 38's larger than anything we've seen before. So that's because, a lot of those low information density things turn out to be like there was a bunch of ones, but some of them were supposed to be ones with emits. Same thing here. 3's, but now are 3's with emits. 4's, a few of them now have 41's in them, and so on. So a lot of these are actually terminal states, which is cool. And one thing I need to add actually is like an enum translation, right? Because what I've got right now is, if we look, I have this lexer fsms.h thing, right? And this gives me lex state, and so on. And really what I want to do is I want to say that the end code won't use this lex state. I want it to use an enum that recognizes this for reasons that are difficult to understand. If I don't, without me taking a lot of time to explain it, but I want to basically, except for this default one, shift them all up to their higher set version of themselves. So without a parser to do that part of the meta generation, that's going to be a pain to sync these two things up. So I think I'm going to skip getting that working for now. And instead we'll just say that in the code, whenever I get an emit state, I'll then subtract lscount out to get the original state. Yeah, that seems like a fine way to do it. Yeah, okay. So let's break here and switch over to trying to get the lexer to work again. So new lexer.h, 48.4. Alright, so white space skip FSM, right. So anything that I took out, I'm going to just drop it back in for now. So where are my, okay, here's generator.c, pp, and then I want white space skip, right? And I'm going to put that back in, just temporarily. And same thing with the int FSM, because that one is gone now, and I don't want to try to replace all of them at once. Okay, now, where's main FSM? Alright, so right now we only have, basically we're going to have two different cases. So we're going to have, if the s.pp state is exactly equal to lspp default, we're going to do one thing, and then otherwise we'll do the old thing here, because we don't actually have the whole system set up to handle multiple pp states yet. We haven't got to that part of the plan, but we can do the rest of this using the lookup table instead of a function now. So the way this changes is now all we do is we say s.fsm dot state state equals and then we're not pre-multiplying the states in the table, so we'll do something like main. Let me look at my tables. Reload them. That's a bug. New lexer.h. Okay. So we've got these tables here, and I'm gonna do an FSM EQ classes lookup first. So I need to do, okay, so it's basically gonna be FSM the new state is whatever I get when I do the take the FSM table, do the current state, the current state times ls count plus times num EQ classes plus let's see, then I need to look up in the EQ classes array with C. Alright, so now we can replace that function call with just a couple of table lookups and a multiply and an add. Alright. Now I just need to pull main FSM back in for that. The other cases that aren't generated yet. Main FSM. I think I originally was copy pasting and then I decided to cut paste, and then I was right the first time because I knew I wasn't going to try to get the whole thing at once, and then I got a little greedy or something. Alright, so there we go. Now what I don't have is I don't have me running that yet. Oh shoot, we don't want to do this. Yeah, pull out. Because that's in like crazy town test mode. So if single items, what we're going to do is we're going to switch to doing no chunked mode yet. We'll do one repeat just for a correctness test, right? Experiment. We passed 0 out of 20 tests. That's not very encouraging. So back to the experiment code again. Please raise the verbosity level to a 0. What kind of failures are we getting here? So we're just not emitting any tokens is what you're saying. Oh, I know what's going on. Okay, so main FSM table, and then what we need to do is basically this logic here is still looking at the emit, which is never happening. We need to say while s.fsm.state is less than ls count, and then right here we can say we emitted a token if s.fsm.state is greater than ls count, right? Or equal to, right? So that's how we know if we emitted a token at the end of the loop. And then as I said down here, if we are about to use the state, yeah, right here we're about to use the state, so I'm going to do if s.fsm.state is greater than ls count, s.fsm.state minus equals ls count. There we go. Let's see if that... still not working. Okay, what's wrong with that? I wonder. This is if we're in default mode. We're still not emitting tokens, which is a little weird. So state is never becoming greater than ls count, or we're looking things up in the wrong way or something. So let's take a quick... Yeah, let's take a quick look at that in the debugger now. This is the debugger for the wrong program. We'll save the changes, and then we'll debug the experiment code. Yeah, it's true that multi-line's not working yet, but we're getting... I can see right here in my output that like I'm not outputting any tokens, because it says that the size of the original stack was 60 and not 0. They're all outputting 0 tokens, which means emit is just never being set to true for some reason. Debug experiment. But thank you for reminding me, because it's not going to work totally correctly until I add the multi-line thing as well. But I want to see why we're not getting emit token to happen. There we go. Actually, I also want to kind of go right here. All right. What? s.pb state. Are you telling me you always... less than ls count. What's going on here? This doesn't make any sense. Oh, are we not, like, up to date? Okay, what? Okay. Are you just spinning in the white space skipper for forever? Oh, shoot, I see the problem. So that should be WFSM equals, for one thing. Passing 2 out of 20 tests now. I wonder what went wrong in the other ones. They're all off by small things here and there. Yes. Okay, so, I'm curious to see what exactly is wrong with that. So let's take a look at auto tab. Okay, so tell me what is wrong. No. Where's the other one? There we go. This one. Right. There we go. There we go. There we go. Alright, so the first thing was a token range mismatch. Huh? So the correct size is 16. We gave a 76. Start is 0 on both, so that's good. This is the auto tab. Curious to see what happened there. Interesting. So it did not handle the comment quite right for some reason. And I'm curious why that is. So let's go to the table generator. Comment related stuff. Is there something important? Is this about multi-line already? I don't think that should be, because that... hard to say though. Comment... free. That's just changing the state. That's just emitting. That's just changing the state. Comment. If you see a new line, you emit a token. Comment free. Somehow it's getting into a bad state and then consuming the next thing. But this isn't quite what I would have expected. Is there anything else in this function I'm forgetting about that doesn't follow the rules of a finite state machine? Or passing an LSPP default, right? Yes. Okay. So what I could do, be a little bit laborious, but it's possible, is pull this up and then walk through this the first time it happens, and just keep track of the state transitions as they go. So let's see. Here's s.fsm.state, and it's currently a 0. And then here is the C that we put into it. Okay, so we put in a slash. Alright, so here we are. Oh wait, what I need to know the number the slash has. It's a 47. So here's the worst part. Oh wait, what I could do is look up main FSM EQ classes C. Okay, so it's EQ class 16, and so that should transitions us to which state? State 14. Alright, now the hard part is actually going to be tracking which state goes with which number, actually, now that I think about it. So 14, if 10 is the first line, then I subtract 10 from any one of them, so that's comment pre. That's cool. So it got to that state correctly. And I'm going to assume it then transitioned to 15, which would be comment, which is cool. Then it stayed in 15 as it saw various things. Okay. 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 E is fine. Space is fine. H is fine. E is fine. R is fine. E is fine. Slash R, what does it do with that? Stayed in 15 there, which is correct. New line. 52. Okay. So it saw the new line and it's transitioned to 52. So 52 should mean comment plus which is 15 plus the number of states, which I believe was 36. But that's not right. That would be odd. Was it 14 that was the no, comment pre was 14. This was 15. How did we end up at 52, I wonder? That should be 51, I think. Right, because if that was a 51, that would mean that it was from there. So it feels like it's coming out as comment slashed when it's trying to emit for some reason. So are the emits not calculated quite right on the thing? Generator.cpp. I'm doing ls count to add in that, right? So that's if we didn't emit, then multiply by ls count and add that in. Ls count is 36, right? So how did we get a 52 there when it seems like we should have gotten a 51? Yeah, we got 52 in 2 spots, and we got 51 in a number of spots too. Huh. This right here is a new line. That's the only thing that ends the line comment. That's the only thing where the 52 is showing up, so interesting. Interesting. So I want to see if we go back to the other one, right? So I need to cd dot dot slash dot dot cd build dev env for FSM gen dot exe. Does ls count equal 37? Yeah, you're right, it does, because the max Okay, so forget all that. I was just being silly. LS count is 37. There's 37 states. Because if the max state is 36, then that means there's 37 states with a zero indexed system. Okay, so that's correct. That means that part actually didn't fail at all, which is a bit weird. Let's run through to there, and then when we come out here, state should be 52, which is greater than ls count. Emit token. So we're emitting a token, right? Did we emit a token? Yes, so we break. Then we come in here, is state greater than that, so we go down to 15. Yes, that's the one we wanted. Then we take a look at PP state, we look at this. Comment type, comment flags 0, unget white space. What happens when we unget white space? Boom. Plus one more, so we're back to the /r, because after a comment we need to re-lex the white space, and we don't want to. Yes, it's a bit of a hack, but it is fine. And then we emit a token. Token size equals 16. Token start position. Is this working differently now? Was there a bug that got fixed or something? Okay, so it's definitely not working now, so that's good to know. Boom, boom. We emit the token. So we come back around to here. Now, oh shoot. No, I think I overreacted again. That's wrong. Boom, boom, boom. Okay, so FSM is back to zeros. Yes. Okay, so what happens next? We get the next character. What is the next character? We should have skipped new line, so we're looking at a bracket. And so we end up in what state? 37. So we agreed to emit that token. And we come out. Blah, 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 blah. Emit this token. If position override, no. So size equals tokens. Did we merge these tokens for some reason? Flags, blah, blah, stays 0. State flags, fine. Push token non-alloc. Okay, did we end up merging the tokens? Is what I want to know. Tokenize greater than 0. Previous token. Out token. We attempt to merge. We come in here. Wait a minute, what's the token type here? Token comment still? How did we get to that, I wonder? Yeah, we need to back up, because what happened was we labeled that as a comment for some reason. So there's our bug. 1, 2. Okay, so coming through here, when did we give it a type of comment? Or did we just not give it a new type? That's what happened. Oh. So what is going on there? Is it because I did greater than ls count up here and I was supposed to do greater than or equal to? Yeah. So that should be greater than or equal to, because it's not updating the token type there. Okay, cool. So boom, boom, generator.cpp. No, wait, no. This is in the new lexer. Greater than ls count. Yep, there it is. And rebuild. Alright, let's see if we're passing the experiment test now. Still not matching. Alright, so, unchunk passed 0, 1. Token flag mismatch at token 20. What you talking about? Token flag mismatch. Show me token flag mismatch. Show me. He says 16, he says 0. Which token is this? What is this token? String constant? That's the multi-line thing. Okay, gotcha. Alright, so we need to add multi-line, but first I want to see how many things are like besides the things that happen to test multi-line, is it all around correct besides multi-line? I think I will be able to tell if it is. Now it's running 21 tests? Is it becoming the wrong? Do I need to like go to code before I run experiment? There we go. Okay. So, yeah, so we're just missing that one, which is that one right there, the one that we were on. Okay, so let's add multi-line real quick, just so we can get everything working. So here's the generator. Multi-line's not too complicated. So let's look at the tables real quick and pull up a new one. So every time we look up in this table, we get information about what state we are in, and whether we emitted is encoded in whether or not it's greater than this other thing. The only other thing we have to do, science to be done, yeah, 4coder runs on Windows and Linux right now. Although the Linux version is still pretty new, and we're working on it to get it up to you know, full functionality correctly. Like, it's out and it basically works, but it's got issues. We're getting there. And then there will be a Mac version once the Linux version is pretty solid. Okay, so this table here is going to have another table that's going to be a bunch of zeros and ones. It is what it is. Even though I'd love to not have a bunch of, like, another copy of this table. The only other option I could think of is none of these are using the high bit. I could do a masking thing, right? And what I mean is, if it's multi-line, I would set it to the high bit to something, or I could shift all these states. You can't do that because these need to be offsets. The states are offsets into the lookup table. So, yeah, so it looks like if it's going to be multi-line, it's just easier to make a separate table for it. Okay, so to make a separate table for that, here's the reduced transition table. I'm going to grab another table of similar size, or you know, I'm not going to do it as two separate loops. That's dumb. That's dumb sauce. We're going to do reduced multi-line table, and that'll be the same thing right there. And then at each position, what we're going to do is we're going to say set FSM. Set the emit token to 0, that's fine. Do all the stuff you were doing, and then set multi-line to 0. And what I want to know is, we should do the ++I afterwards now that it's going to be used twice. Reduced multi-line table, and the answer there is new FSM.multiline. Alright, and then when we're going to generate the table, we'll do this again for main FSM multi-line table. Alright, and this is something that's like a vestigial part of the old thing. I'm going to see if I can eliminate it, because if we don't actually need this, it'd be nice to not have two tables for this particular finite state machine. Or at least like two main lookup tables sort of thing. Like, you know, we already have two tables here, but anyway. Reduced multi-line table. Alright, so let's try and run it. Cool. Let's open up the tables and boop. Now we have this, and there's like barely anything in the world that ever actually does it. See, this is why I don't like having this multi-line table, because there's two ones in the whole thing. But the other option would be to make multi-line a pair of states. So there's really the only reason to have that is to reduce the number of states, but I don't think it would kill to actually just add in two more states to represent those states after multi-line has been set to true, because multi-line just basically gets ORed in. And this is obviously like super dumb, but I don't feel like doing that. So that'll involve a little bit of rewriting that I'll do later. Um, but basically the idea will be I'll just, for these two things, when they become multi-line, they stay multi-line until they're done. So we'll just transition to a multi-line version of the same state that'll behave exactly the same way, except that it's the multi-line one. And then afterwards I'll check if it's a multi-line state, set the multi-line flag to true. Rather than having the secondary lookup table. It's kind of really dumb. Alright, oh, well, one other thing I gotta do is the new lexer now needs to use this new table. Which has to happen right here. s.fsm.multiline equals, and this actually has to happen first. What I should do is have a quick pre-computed int I equals, and I'll just grab that because I'm going to use the same I twice, so I can at least get that win, right? So there we go. We look up into two different tables. We ruin our cache. The whole point of the whole project is thrown out the window. Something isn't compiling correctly. Oh, we can't just put a square bracket I. That's not going to get you anywhere. Multi-line table. There we go. And that shouldn't be an equal, that should be an or equal. Alright. So let's see if we're passing that the full battery of tests now. Hey, we are. And look at look at our speed up factor. This is in debug mode, but we're up to 2 again, which was not where we were to begin with. Let's build. Well, I'm gonna take out verbose real quick, and switch over to experiment CPP, repeats 100, and verbose level -1. Okay. And then I'm going to build experiment/O2. Now, I don't expect this to be better yet, but maybe it will be. Like, I don't want to get everyone's hopes up that we're actually doing it, because there's a lot of more win to get still. But we'll see. So before you saw we were getting about 0.95, but we only ran once. We're certainly not slower. I think we're about 0.1 speed up factors above where we were before. Sometimes we're still equal. Alright, I think that that's a win. Okay, so let's see. Oh man, Handmade Heroes in like 30 minutes. I'm having so much fun right now. I wish I had more time to do this. Okay, let's work on that pre-multiplied idea real quick. Let's just hammer this out and get something cool working. So the idea was that we're going to transpose this table, and then we're going to pre-multiply the equivalence classes. Now I want to see in my head if that makes any sense. So the equivalence classes, the size is, there's 30 of them, which means the largest one is the number 29. And on top of that, how large would the multiplication have to be? Well, if I transpose that, how many states are there? There's 37. So it would definitely have to be a bunch of shorts. Our equivalence classes would be shorts. We'd have 256 shorts, which would be 512. So Cuber Caleb, you missed a lot of the leading up stuff that we've done. Yeah, Jesse Meyer points out that because I'm running OBS right now, like all of my statistics are just totally invalidated. When I run off without OBS, I have the new lexer was faster. I'm imagining, since the point of this whole thing is to optimize cache stuff, that without OBS, the new lexer will be way better than it is right now. And the old lexer doesn't really have it doesn't get any of its speed from cache. Like it cache would not be where it wins in the first place. So I think that that would be it. But Keeper Caleb, the basic idea is the whole thing is built as a finite state machine, right? It's so we can turn the function into a lookup table where we store, we compute, I'm writing a generator that computes the value that you get at each particular state and character input and makes a table out of that, so that every time I want to change something, I just change something in my finite state machine function, and then it'll generate a new table for me, and my code will run off the table, because it's faster that way. Okay, so we've done the multi-line table. Now I want to look into pre-multiplying the things real quick. So if these are pre-multiplied, they would have to become shorts, because, okay, we would also have to transpose this whole table. So let's do one step at a time. Let's say that we do a transposition of this table as the first thing we want. So you index by input first, not by state, and then state is just a small offset into whichever index you have. Is that a good idea? We'll see. We'll see. Right here. So here I'm going to go back to this version. Boom. And then what we're going to do is say that even when we print these tables out, we're going to do the transposed version. Okay, so now we're going to transpose all these tables. So let's give that a shot. I don't know if that looks right. I can't remember what it looked like before. That looks right down there. So basically this is input for EQ class 0, 37, 38, 39, 40. Yeah, that looks right. And then for each equivalence class, what will basically happen is we'll take a look at which equivalence class we're in. Then we'll use that to index in. So the reason I'm concerned about this is a lot of the states, you'd like to load in the memory for one state and then perpetually stay in that state, because a lot of states, like here's 60, all the 60s kind of go to each other except for a few, right? All the 50s kind of go to each other except for a few. And so it's not spectacular that you have a state. Well, those are actually terminal states. I guess that's a bad example. So like, I think these 4s are all 4s going to each other. Okay, you know what? I take it back, because I think most of them, it's maybe not going to be a huge issue. Like, the only things where it's going to be an issue is like these 4s all go to each other. These 3s here, well, those are all just going to 3 actually. So yeah, these 4s all go to each other, and you'd like to have all of them just in memory and constantly read out of them. That you don't have to, like, every time you look at a new EQ class, you jump to a different row and read, because that's going to cause cache failure. But I don't see how else to do the pre-multiply, so just as an experiment, I want to say, what if I transpose those tables so that I have to rewrite the new lexer.h this way. When I compute I, it's not this that gets multiplied, the state gets added in, and it's the EQ class times ls count. Alright, and now I run a quick experiment test to see, oh shoot, I should turn off the thing so I don't waste a bunch of time. Experiment CPP, here's one, here's, yeah, okay, there we go. Experiment. I just care about correctness. So there we go. That's correct. Alright, so we've done the transpose there. And now, let's try pre-multiplying. Yeah, Angus Holder, the idea is that it all lexes on, like, in one perpetual stream. It is chunkable, so you can pass in a chunk that you want it to lex and then stop when it's done, but you don't really have a good way of saying, like, and you can also say, like, stop after one token if you want. But the point is so that in 4coder it will be used as, like, one perpetual input stream to lex the whole thing. And so I'm doing a context-free lexing, and then I'm doing all the context-sensitive stuff on the parsing job afterwards. Okay. There we go. And then now what we can do is say that when we're generating these things, we can pre-multiply the EQ classes. So where is that? EQ classes, there we go. That's going to be a short now. And we're going to go across all of them and multiply each one by ls count while we're going so that they're pre-multiplied. Alright, so now with these pre-multiplied ones, oh, I need to change the new lexer to not do that multiplication anymore, because now when it looks up I, that is just wrong because we've pre-multiplied it. We don't want to double multiply. Not sure what's going on there. That seemed bad though. Are we getting bugs? Yes. Comment. That's a floating constant. Huh. Which token is this? The first token. Interesting. Which file is this? It might just be that we have like, yeah, okay, so we've done something that's totally bogus. Let me check the tables real quick. Control-Shift-O. Alright, so those look like pre-multiplied equivalence classes to me. Keeper Caleb, it doesn't. I don't differentiate between those. Between the bit shift and ending a template. But that's fine because you can just, when you know you're parsing a template, you'll treat the bit shift as a valid operator then. You can totally lex C++ context free. It's just not what most people do because I don't know why they do it the way they do it, to be honest. I mean, literally, if you just start with C and look at it, all you have to do to make it work is start with a context-free parser and add a single hash table. And C++ adds a few more things that make that not work once you get into like templates and stuff. But like, and that's also assuming that you like have you're looking at it after pre-processing situation. If it's before pre-processing, then all bets are off. Alright, so let's see. Something went wrong, and I don't know what. But we generated those. Wait, where do I have the EQ classes? Yeah, right here. So right there, we were saying that we would multiply by ls count right there. And then our generator, where do we multiply by ls count? Here, where it is not happening. I'm not sure why it broke when we made that change. Can I revert back and get back to working? Experiment. Yes, I can. Okay. So that's weird, right? I'm not wrong in thinking that's a bit weird, am I? So what am I thinking about incorrectly here? So our table dot C. Here we are, and what we're doing is we're pulling things out of this table and multiplying by ls count. And all I'm saying is I want to multiply by ls count here before I put it in the table. And then in new lexer.h, we're storing that in an int, so it's not like it's getting rounded incorrectly. Wait a minute, I have a theory. So generator Put more multiply in right there. Alright, new Laxer. Yep, everyone's ready to go. Let's try this just one more time. Huh, it's totally broken now. Why would that be? Why would that be? I'm stumped on this one. Very strange. So you're saying that if I multiply here, and I don't multiply here, that it works. I wonder if... Okay, how big did those things get? Reload. Yeah, they didn't get big enough to overflow a short. 120. Yeah, 122. Wait, they didn't even get big enough to overflow a char, did they? What's the biggest one I got? 230? 240? 250? No, 260. I don't think that those even need to be shorts, which would be kind of magical. Yeah, and I've considered that maybe ls count isn't the same between them, but it's a shared header that is generating ls count between them. Like, ls count is just an enum that's in the same header included by both. I don't think that like, plus other things rely on ls count across the two, so that doesn't explain it. Okay. So when we're generating it, we multiply the EQ class by ls count. And so things that were like 0, 1, 1, 1 become 0, 37, 37, 37. Now, what does that 37 mean? That 37 means that when we add it to the table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Yeah. So that puts me right here on the table. And then it looks up the next state. And I'm multiplying the EQ class by the count, not anything else. What? Alright, so basically what it comes down to is at some point I get a different value here based on whether I'm using pre-multiplied or not pre-multiplied, right? So let's try something. Let's say we're going to do this twice. Boom. Pre-multiplied, and here we'll multiply by ls count. Right? And then in new Lexer, I'll add a quick little point where I say, look, I'd like to assert that this is supposed to be equal to this. So now tables should have both of them. And it totally does. And it makes sense. 20 times 37. 20 times 37 should cause there to be like a 600... Oh, I know it's going wrong. I get it. I get it. Okay. So it does have to be a short. And that's the problem. I'm not generating it with a short in the generator. I'm truncating it in the generator right here because EQ class is an unsigned short. It is not an unsigned short. It's an unsigned char. So we're going to finally get this right. We're going to multiply by, or do table items, actually, where I have to look. Do table item. I'm going to turn that into an unsigned short. There we go. And now, boom. Now, when I look at my table, it will make sense that it's got to be a short because I'll see, wait, what? Times ls count. FSM EQ classes. I thought, okay, shoot. Times ls count. Boop. There we go. That makes more sense. Okay. And there we go. Okay, and then in the new lexer we don't need to multiply by ls count anymore, so new lexer.h, we don't need the assert, we don't need the multiply. There we go. Now we're up and running. Hey. Alright, so I'm just curious to see if that gave us any speed though, which of course I'll have to test off stream to know for sure. That suggests, oh my goodness, it's so hard to tell. I'll have to definitely try off stream. I guess I needed to be doing an average over more than one item to make it fair. Tables, FSMS, what's the one I need? Experiment. We want 100 of them. Wait, no, I don't want to do that. That's really dumb. Build experiment 2. Run the experiment. Aha, look at that. That actually sped us up according to the really lame. Oh, I need to go back to code though, maybe. According to the really lame numbers I get when I run with OBS running. Maybe not. Yes. About the same, maybe. Hard to say. Alright, so that didn't make a huge difference. What else can I do in 2 minutes? So we got these tables here. I'm going to rewrite that off screen because it's too boring. So the next thing I got to do, really, is I want to have, we're basically, oh, is Handmade Hero starting? Alright, well, I'm gonna wrap up then. Basically, what I've got to do, and I'll probably do a lot of this off stream, now that I've shown the idea on stream, I wanted to do a metaprogramming stream. So there it is. Here it is. Here's what I'm going to work on, and maybe we'll see some of this next week. Right now, this is only working for the default preprocessor state. It doesn't work for the whitespace skipper. It doesn't work for really the other finite state machine things that are set up. So I have one finite state machine working out of like multiple finite state machines that I want to work. And so what I'm going to do now is take this code, set it up so that I can generate finite state machines using this system, but by just plugging in different parameters for where the finite state machine data should originally come from when you run the function. And then I'll have the generator just spit out all of the data, the EQ classes, the number of EQ classes, you know, the table, and not this table, but this table for every single finite state machine, and then all of the program will be converted to little finite state machines here and there. And so we'll try to get that little like 0.1 speed up that we got today. I'm going to get that on every single state, not just on the like default state. Like, so that'll be the whitespace skipper will be huge, and also the preprocessors. And then after that, I'll revisit the possibility of find any other ways to optimize too, because there are other things I got to do all over the thing to really speed it up. But there you go. Um, uh, so that's it. That's the whole stream. Thanks for joining me. I'm signing off now. Let's go watch Handmaid Hero. Bye bye.